Exponential functions. Exponential functions are functions of this form. F of x equals a to the x. We call a the base. X is going to be our power, which is going to be our input. For example, suppose a is 1/3. Then f of x would equal 1/3 to the x power. So if I wanted to find f of 2, this would be 1/3 to the second power, which is 1/9. When it comes to graphing exponential functions, we can start with a base graph. F of x equals a to the x. And I'm going to make a t-table here. Suppose we have our inputs x and our outputs f of x. And let's start with -1. Well, that would be a to the negative first power, and that will get us 1/a. If x was 0, we would have a to the 0 power, which is just 1. And if x was 1, we would have a to the first power, which equals a. Now, generally, a is going to be positive and not equal to 1. Let's go ahead and plot what we have. Let's say this is -1, this is 1, and this is 1. When x is -1, we're at 1/a. That's some fraction. Let's just assume it's somewhere down below here. This is just for getting the idea what the graph of f of x looks like. When x is 0, f of x is 1. And when x is 1, f of x is a, whatever a might be. Now, if we were to continue this pattern, we would notice that the graph of f of x would never pass the x-axis. It will remain positive. And this is what the graph of f of x would look like, with a horizontal asymptote at y equals 0. Next, we have the natural number e. The natural number e is an irrational number that often appears when dealing with exponential functions. E is about 2.718. Now, it is irrational. That means it's a decimal that's going to continue forever. If you needed to work with the function e, it might be a little easier to substitute e for maybe 2.7. This will give you an idea of where things are on the graph. But remember, this is an approximation. It's not exactly e. That is all.